You may have heard of this word before. It's called trigonometry. This also deals with right-angled triangles, just like Pythagoras. Except there's one small difference. Pythagoras is all about the sides of a triangle. Trigonometry has to deal with an angle. So it's looking at the insides of a triangle. But they always deal with right-angled triangles. You may see this little squiggle. We did mention what this little squiggle was in another video. But that squiggle is what we call theta. And it's the unknown angle. In other words, it's the equivalent of saying x, but for angles. But what is trigonometry? What does it mean? Well, it's got to do with ratios. Trigonometry is the relationship between angles and the sides of a right-angled triangle. In other words, it's got to do, it's a certain ratio function that we do with the angle can be calculated by referring to the other sides. So what do I mean by sides? Which one's which? Do we still use the a squared, b squared and c squared of Pythagoras? I suppose you could. However, we've got specific names. Depending on where your angle is how we name them. For a start, you might remember we talked about at the very beginning of Pythagoras. The longest side is what we call a hypotenuse, which is not a very large heavy-set creature in a zoo, but rather it is that longest side. The side that is opposite the angle, funnily enough, is called the opposite. It's the opposite side to the angle. The side next to that, or adjacent to that angle, is called the adjacent. Now, if I was to, that's all reference to this angle here. What about if I was talking about this angle up here? Let's draw it. So if I was talking about this angle up here, well, the longest side is still the longest side no matter what I draw. So this is still the hypotenuse. However, this side, since now this side is opposite that angle, this is now the opposite, and this is the adjacent. And what I'll do is I'll even colour this in, so we're colour coding everything. So the opposite is whatever the angle I'm talking about, the side opposite that is the opposite. Whichever side is next to the angle I'm talking about, that's the adjacent. I've got here 30 degrees, and I've got a side here of 5 centimeters, a side here of 10 centimeters. Well, the thing is, we've got a specific interesting ratio that we've got here. We're going to talk about the three types. There's sine, cosine, and tangent. Now the sine function, so sine, so again, think of sine as a ratio. So sine means the ratio of the angle is equal to the opposite divided by the hypotenuse. So you can think of it this way. Think of it as that is like a little fraction thing. So the fraction of this particular angle is equal to the opposite over hypotenuse. Not strictly how it works, but there might be a way to understand it. Now, so the opposite over the hypotenuse. So I've got here 30 degrees. The side opposite to that 30 degrees is 5. The side adjacent to that, the side adjacent here we don't know. The hypotenuse is over here. So this would be sine 30 degrees is equal to 5 over 10, which is equal to 1/2. So sine of 30 degrees is equal to 1/2. Now why is this useful to us? Well, if I've got this particular information, I can work out things. So for example, let's just say we had an unknown side. Now let's say I had this triangle. I need to find this side, but I don't know what this bottom one is, so I can't use Pythagoras. Okay, so I'm going to use my little bit of knowledge here. I know that sine theta is equal to the opposite over hypotenuse. I know that sine of the angle here is equal to the opposite over hypotenuse. So, in other words, if I've got my opposite is 4 centimeters here, but I don't know what my hypotenuse is. Now, the angle here is still 30 degrees. But hang on, did I not just work out earlier that sine 30 degrees is equal to 1/2? I did. So therefore, 1/2 is equal to 4 on x. That's interesting. 1/2 is equal to 4 divided by something. 4 divided by what gets me 1/2? 4 divided by what? Of course, 8. So, if I change that, yes, that works. So in other words, x equals 8. So in other words, this side is 8 centimeters. And look, now that I've got those two, I can now work out what this other side is. I could use Pythagoras for this. So I know that c squared minus b squared is equal to a squared. Therefore, 8 squared take away 4 squared equals a squared. 64 take away 16 equals a squared. So that should be equal to 48. It's equal to a squared. A is equal to the square root of 48, which will be some number, but right now I'm just going to leave it as the square root of 48. So that is how I can combine both trigonometry and Pythagoras to find out sides. There are a lot of different problems that involve both. So this is a handy one. Now, I was able to figure out that sine 30 equals 1/2 based on my previous triangle. But how do I know if I don't have a triangle to compare with? Sometimes I might ask you what's sine, 162 degrees. I haven't got every single triangle. This is where the calculator is helpful. When you have your calculator, you'll find that it has some different functions, depending on what yours looks like. Make sure if you're using your iPad that it is selected to scientific mode, so it needs to be on a scientific calculator. But you should find buttons that say sine, cos, or tan, or it should say sin, cos, tan. And one thing to make sure that your calculator says DEG, or degrees, or D, or as long as it doesn't have R for radians. It must be in degrees. Radians is another form of degrees that we use later on. We talk about those in Year 11 and Year 12, but right now we'll be just using just degrees. So, if I was to type in sine 30, it's come up with 0.5. So that has already told me the answer, and I can use that to find unknown sides. Now there are two other types of ratios as well. We've got a cosine and a tangent as well. So here is our right angle triangle. We've got a hypotenuse, the opposite, because I'm talking about this angle here, and the adjacent to here. So I know that sine degrees is equal to the opposite divided by hypotenuse. That's the ratio of it. Cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. This sine, cos and tan are I suppose you could say just different ratio types. In other words, they find the same answers except only if you're dealing with certain signs. Now, the only thing you need to make sure to remember is you need to remember all the different ratios. But how do you do that? How do you remember that sine is opposite over hypotenuse? How do you remember that cos is adjacent over hypotenuse? How do you remember that tan is opposite over adjacent? Well, the first things first is remember that they're all divisions. So they're all one side divided by another. But there's also an easy and handy way to remember, and that's by getting rid of a lot of letters. First thing first, I'm just going to get rid of all the letters, so I've just replaced every time I see an opposite with just O, hypotenuse with just H, and adjacent with just A. Now what I'm going to do, so I know that sine is opposite over hypotenuse, cosine or cos is adjacent over hypotenuse, and tan is opposite over adjacent. SOHCAHTOA. 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 Whatever makes it easier for you to remember, just remember that chant, SOHCAHTOA, SOHCAHTOA, and that way you can remember all the different functions. So.